Hey, what's up? Jason here from Unity3D.College. Today we're going to talk about finding game objects. More specifically, we'll talk about 3 different ways that you can find objects. We'll talk about the performance characteristics, and then I'm going to dive into which one I use and why. So here in our sample scene, we've got 3 different objects here that are all disabled. There's a GameObject.Find, a FindObjectOfType, and a FindByTag. I just named these to match the method that we'll be using when we enable them. So if we look at GameObject.Find, you see it's got a little test script on it with a number of things to spawn and a number to scan. And it's the same for the type and by tag. They're just slightly different scripts that find the objects a different way. So let's open up this test script, and here you'll see the 2 fields that were showing up in the editor. They're private with the serialized field attribute so that they show up there. Then we have an array of strings that are names. So this is just going to be the names of the objects that we create, so that way we can find them. And in onEnable, we create a new array. So we initialize this array to the number of things that we're going to scan. And then we loop through the number of things that we want to spawn, create a game object, just making a cube, give it the name for cube 0, cube 1, cube 2, and so on. And then we fill those into this names array. Now in our update, we just loop through them and call GameObject.Find. Now the reason that we're using the array here instead of putting in the name is that if we just did something like this and just copied in the name generation right here, this concatenation of this string is going to cause a little bit of garbage collection and extra work that's not really what we're trying to measure. Looking it up in an array index is not, though. So once we just pre-create all these names, we get a more accurate test for speed and garbage collection. So let's try that one out. Let's jump into the editor. I'm going to hit play, and then we'll just turn it on and see what the performance is like on this. So there we go. It's on. We have 1 cube spawned. We're scanning 1,000 times. And if we find the one right here, script, if I can select it, terrible at this, there we go. You see that the timing is relatively quick. We're at 1/10 of a millisecond, or 5/100ths. It's nice and fast, right? So let's stop and let's take a look at another one. Let's try FindByTag. Now I'll open up that script again too, just to give a quick idea of how it works. Same thing here for the fields. Same thing on the onEnable, except here we're setting the tag to find to just be whatever the cube name is. Actually, this is wrong. This should just be, well, it'll be fine because it's going to be cube 0. We're only creating 1. But really, I think this should just be cube 0. And just get rid of that because I don't want to create a tag for every single object. We're just creating one that I've already created in the editor. And then we're finding it right here on what is now line 26 with find game object with tag. So let's try that out. We will turn it on and hit play. Oh, I also want to point out that we do have to create the tag in here. So you actually have to go in, hit add tag, and create the tag. Otherwise, you're going to get an error that the tag's not there, and then those errors will totally kill your performance and your profiling. So here we go. We hit play, and we've got our cube there. We've got our profiler running. And you see that big spike at the beginning. Let's just kind of watch for a second. And then go find our script run behavior. And here you can see the timing is not quite as good. It's not bad, but it's not quite as good. So about twice as long, it looks like, for this. Of course, remember that we are scanning 1,000 times. So far, none of these are really bad for performance, even in an update loop like this. They're not great. I definitely would not want to do this 1,000 times a frame and just start eating up those resources for no reason. But you can see that it's not a huge hit. So let's try the last one. And the last one is FindObjectOfType. So open that up. And here you'll see that we're creating the cubes just like before, but we call FindObjectOfType and we just give it mesh renderer because these cubes all get a mesh renderer. So let's turn that one on, hit play, and see how that does. All right, there we go. We've got our cube. It's got its mesh renderer. We go to the profiler, and as you can see right here, this is actually significantly worse performance-wise. Not only is it generating a bunch of garbage, you see the GC Alex popping up, but the time is, we were looking at maybe a tenth of a millisecond on the last one, and now we're at 23 milliseconds. So significantly slower here. All right, so now that we've seen kind of the difference here, and of course this was only with one game object. If we turn these up, we'll start to see these numbers start to get worse and worse and worse. But the thing that I wanted to point out here is that FindObjectType is actually slower than find and find by tag, which really is a bit of a surprise, because you would think that, hey, maybe going and looking these up, by string name is going to be slow. But when you think about it, FindObjectType is probably using some sort of reflection or something else where it really has to dive in deeper. So what do I recommend? What do I use out of these? Well, it's not find by tag, because, to be honest, I really hate tags. And the reason for this is that they're just not very easily exposed in code. It's very hard to tell that a game object is tagged with something or not tagged with something. Like maybe this is tagged with cube 0, maybe it's not. If it's not tagged or it needs to be tagged, it's just a lot harder to figure out where the issue is. So I've run into this many times in the past where I'm debugging a problem, trying to figure out why something's not working, and then spend half hour, even longer, and eventually find out that, oh, the tag on this object wasn't set. Usually it's because somebody recreated the object, they deleted it, recreated it, and when you're going through that process of, like, oh, hey, I need to make my own find by tag, and I go create a new one, and I recreate everything, go GameObject.Find by tag 2, because this is the awesome version, and I look back over here and I'm like, oh yeah, this one has a test script by tag. So I copy it, select this one, go in, paste it, and oh yeah, there, perfect, right? Except I missed the tag thing, because most people do. They don't look like, oh, whoops, this one wasn't even tagged. But imagine that was tagged. Like, oh yeah, look, I totally missed the tag, and now this thing's broken. And it gets a lot worse when the project is bigger and there are multiple people working on it who don't remember or don't know all of these intricate details. So I, again, generally try to avoid tags for that reason. Now, the same could be said for GameObject.Find, unfortunately. So while this is definitely the fastest method of these options, of these three, it's also the one that kind of drives me a little bit crazy, because as soon as something gets renamed, this no longer works. So you go in, you rename, you fix the name of a game object, or you just come up with a better naming scheme or just a better name for the thing. Suddenly the code doesn't work, and there's no indication. So if something is looking for, hey, it wants to find this object by this name, and I change it to a 2 there, or Jason's or whatever, maybe I get rid of that prefix and we're like, we don't need that anymore. Now it no longer works because the name no longer matches, and there's just no indication that, hey, this is referenced by string name somewhere. In fact, generally, I'd recommend avoiding referencing anything by the string name. So yes, that does mean that generally what I prefer to use is FindObjectOfType. Now, you might think like, oh, well, look at these numbers. That's insane. Those are terrible numbers. You're right, they are. Those are terrible numbers. But doing this in an update loop is also terrible. You shouldn't be searching for 1,000 objects every single frame. There's really no reason for it. In fact, most of the time when you do these GameObject.Find calls, what you should be doing is caching them. So instead of throwing away this found one, I'd be adding it into an array maybe, or just caching it locally. Perhaps I'd go like, let's say I went, well, this is going to be a little bit weird because I'm creating them down here. But if I had another script, there's like a private game object array of found things. What I would do is here, I would just add these. And I'd probably make this a list too. List of, not an audio listener, a list, control period to get my using statement, of game object, found things, and I'd make it like a new list. And then here I would just add this to the list. Like var found and go found things dot add found, and then I would just reference the things from this list. Oh, that's not right. It's found.gameObject. So hopefully you get the idea. Generally, what you want to do with these is cache this stuff and make it accessible to your code that needs it. later on without having to find it again. You don't want to keep finding objects ever. So while this is, got an extra semicolon there, while this is a little bit slower, I mean, technically it's a lot a bit slower, a single call to this is not going to make a difference at all. And a couple calls isn't going to make a difference. In fact, let's take a quick look at that. Let's turn this down to like 10. So imagine we're doing 10 lookups every single frame. Still no good reason to do that at all. But if we were, let's see what the numbers look like. I think you'll be surprised they're relatively quick and not an issue at all. Well, hopefully you're not too surprised because I keep saying it. Let's see. Script update, where is it at? I don't even see it on here. Well, it's here somewhere. Here, let's pause and take a look. Nothing. Yeah. Either I'm blind or it's way... Oh. We have to turn it on. Let's do that. Then we'll go to current. There we go. Here we go. So there's our script behavior. And you can see it's at 0.38 milliseconds. Still allocating a little bit of garbage. Again, it's not perfect. It's not the fastest thing. But what it does do is give you that compile time safety. Because if I go in and change the name of this script, or change the name of the, I guess it'd be the mesh renderer script, or whatever script I was looking for, and I rename that, the code is automatically going to update, it's going to work, and I don't have to just know that there's some secret string reference that's not found by the code editors. So that's why I prefer find by type, and that and the fact that if I find an object by name, I'm probably going to call get component on it anyway to get that component that I want to actually work with. So here I'm kind of doing both. I'm finding the object and getting that component and ideally caching it right after. Anyway, I hope this is a little bit helpful. Again, it was a bit of a surprise for me when I first found out that GameObject.Find was actually fast. It's kind of a shock. And there are probably some situations where that's not the case, where GameObject.Find falls apart, perhaps with a large number of objects, although that's not really what I saw in my testing. But there may be some other weird situations, perhaps if the hierarchy is adjusted or something. Anyway, again, thanks for watching. Don't forget to like, subscribe, and if you got questions or suggestions, other things you'd like to see, just drop a comment below. And that's it. Thanks.